McQuaid here with the cough and with a short video, or actually it's going to be kind of a long video on using SQLite 3. So I'm in the Files tab in Canvas, and one of the subfolders in here is SQLite examples. And if I click on the three dots next to this, it's going to offer to download this. And it's going to take a little time here. And then it's going to produce a file called course-files-export.zip that's going to go into my downloads folder. So I'm going to open a terminal, and my terminal is going to look different from yours. I'm currently in my database lecture folder, and I'm going to change to my downloads folder because that's I know where it's downloaded it. I'm going to look at this file, and it's been downloaded, and I can say unzip-l for list with this file name. It'll tell me what's in there. So there's a further folder called SQLite examples with inside that a whole bunch of stuff. So I'm just going to say unzip without the L, and it will unzip all those files into a folder called SQLite examples. And then I'm going to change to that directory. By the way, my terminal looks different from yours, I'm sure, because I'm a habitual terminal user, so I've done a lot of things to modify it. And I can show you those things if you're interested. And there are a bunch of files here now, and we can see that several of these files are identical. There's a pets.db file and a petshop.db file that have the exact same size. These unfortunately all have the same creation time. Let's see if I can. I wonder if the creation time. See if I can preserve the creation time. Preserve mixed case. No. Restore tries to restore meta information. Okay, so Canvas didn't store the meta information, unfortunately, so there's nothing to get back. That's too bad. Okay, so I've used a convention in naming all these files where .db is a database and .sql is the SQL statements that create a database. So pets and petshop were both created by petdata.sql. Now I'm going to open them in SQLite 3, or I'm going to open one of them. I'm going to open pets.db in SQLite 3 and just look at it. And you can see that we are running a very recent version of SQLite 3, and that we can press .help. We can enter .help for usage hints. I'm not going to do that yet. I'm going to say tables because I know that that's a way I can find out what tables are in the pets database. And there's only one table in it. It's the pets table. So I'm going to say select star from pets, and here's what I get, that I have 5 pets here, and they're all classified as either kid-friendly or not kid-friendly. What else can I say here? Oh, okay, so dot tables is a SQLite command. All the dot commands like dot help and dot tables are specific to SQLite, but all databases have them, have commands that are specific to those databases. But also all commands respect SQL. All database packages respect SQL commands. That's what I meant to say. And there's not much to this particular database. I can say schema pets. And since that's a dot command, I don't put a semicolon after it. And it shows me the SQL that created this table. And this is very handy for your project because you're going to want to copy and paste something like this into your final report. And I can see that in addition to, um, uh, see, I, where is the, where are the insert statements? Um, how does Pragma work? Pragma table info. Pets, maybe? No. So I obviously didn't, well, let's just exit out of this and see what happens with pet data. Okay, so here are the insert statements. So I inserted into pets. So this is very instructive. So I created pet ID as an integer primary key, and what SQLite did was automatically included an auto-incremented integer as the primary key. So when I said insert into, I didn't have to say insert the integer. I just said insert the name and whether it's kid friendly. So I manually inserted these two columns, and SQLite automatically inserted this column. That's the point that I was trying to make. The schema and pragma are two different ways of getting this roughly the same information. Um, you can see that one of them is the primary key here. And you can see that it's the primary key here. You can see here, okay, here's something in pragma that's not in the create statement, which is that the default value is null. And I haven't specified that any of these cannot be null. So I could have, if I didn't know, for example, since megalodons don't exist in real life, I might not have known whether they were kid friendly or not, so I could have put a null value here. Um, what else can I say about this stuff? Let's see. Oh, I can create another pets. Let me create another pets database. So here, let me show you how I created the pets database. So I said SQLite 3, and I'm going to do a new one now. I'm going to say another pets.db and a less than sign and petdata.sql. And it looks as if nothing happened, but if I do the ls-l again, you'll notice that there's now a new file called anotherpets.db, and that file has the same size, 8192, as pets.db and petshop.db. Okay, so it contains the same information. If I now say SQLite 3 another pets.db and say select star from pets, I get the same information. Okay, now I could just have deleted or overwritten pets.db instead of creating the file called anotherpets.db. Doesn't matter. I'm just going to exit with a dot command. Well, let me first just say help. And you can see that there are a lot of dot commands. So we'll be using several of these dot commands during the rest of the semester. Okay, now I want to show you another one, and I'm going to show you the Chinook ER diagram. Let's first take a look at the Chinook ER diagram. So here's the Chinook ER diagram. Um, the Chinook database is just a commonly used instructional database, and it has about 11 or so entities here. And its ER diagram was created by a different system than what I showed you before. Um, so it has a picture of a key to signify the primary key, and it uses the same syntax in crow's foot notation that I use of two vertical lines and an open circle. And you can see that this is about albums. It doesn't say what the formats, does it? Oh yeah, media types. So these can be CDs or LPs or whatever streaming. I don't know what all they are, but we can find out quite easily by going back to the terminal and saying SQLite 3 um, chinook.db. And if we say tables now, we get a fairly long list of tables. I'll say select star from albums. And you see that we have 347 albums. The last one is Quiana Squatsi from Philip Glass. And we have another column over here, which is, I think, the artist ID. Yeah, the artist ID. So we have the album ID. And many of these I know are, like some of these are famous albums. So this isn't made up data. We have the title of the album and the artist ID. And if we look in the artists table, we probably see that Philip Glass is artist number 275. Let's see if we can find that out. Oh, and there are exactly 275 artists, of which the last one is Philip Glass Ensemble. Now, you might wonder why we didn't write Philip Glass Ensemble in the albums instead of having an artist ID. And the fact is, we might actually change the artist ID. For example, look here, we have Berliner Philharmoniker and Herbert von Karajan, who is the conductor. And then down here we have the conductor, Otto Klemperer, and the Philharmonia Orchestra. So we might change the order to make them more consistent, and we don't want to change who the artist is. It's the same pair, just we order them differently. Uh, Michael Tilson Thomas and the San Francisco Symphony, or some people, there might be Prince in here, he has a different name. Um, that symbol, which is actually I think a Unicode character, so you can actually enter it. And some of these we might have information about, like some of these are artists who passed away um, or broken up, or I don't know. There might be other information about them that we want to keep separately and still have the artist ID. So this artist table could contain more than just the name of the artist. Is my point. So let's see. Is there anything else we can say about this database? Let's look at media types. Select star for media types. Oh, okay. So it's generally files. So it's generally from streaming. Not. I was being very old-fashioned to say CDs or LPs. Okay. So a lot of these are connected to each other, and they contain lots. Oh, if we look at the invoices, we'll see this will be a little more interesting because we'll see the media type. Huh? No, we don't see the media type here. Huh? That's interesting. Invoice ID, customer ID, invoice date, billing address, total. So this doesn't. Oh, invoice items. Let's look at invoice items. That'll probably tell us. And wow, this is a big one. In fact, it goes beyond the reach of my scroll back potential. I can only get up to item 196 here. But we can easily find out what's in there by simply saying something like oops, I accidentally put a semicolon there, but it was a SQLite command. So we have an invoice ID, invoice line ID, I see. So each invoice may have multiple lines. Okay. Track ID, unit price, quantity. So these track IDs must relate to albums, mustn't they? This is one reason why having an entity relationship diagram is valuable. Okay, I see. And this is a big table too. We definitely won't be able to get. So I can just say pragma. Uh, and this is what I've got here. So this is the track ID, the name, the album ID, the media type, the genre. This doesn't really make a lot of sense to me. Why would we do it this way? I think that this is uh, intended to not be a great database, and then you know because it's used in a lot of textbooks, and I think the idea is you try to improve the database. So hmm, maybe it makes sense. I don't know. The more I think about it, the more I think it makes a little bit of sense. Um, yeah, and you may need to price them this way. You may need to price them track by track because people don't buy albums. They buy individual tracks, or they want to buy individual tracks from albums. Okay, so anyway, that's another database that's worth looking at. Let's see what else we've got here. Um, this is actually, so it's typical for SQLite table databases to be not be named DB. I name them DB, but the more common thing is to name them .SQLite. It's too long for me. So we could actually open this as a database in SQLite. We can look at the create statements, and this goes on for a long time, 15,000 rows in this. So this is definitely something you don't want to enter by hand. Of course, there are databases like CDDB that make it really easy because if you have a series of tracks, CDDB can automatically identify them easily. They're not perfect. Cookbook DB. Let's see what's in cookbook.sql. I think I'm going to use this in a later. Oh yeah, I am going to use this in a later lecture. A very simple cookbook. Then there's a corporation one. What is this help.txt? Oh, this is just what you would get from the .help command. And I should mention that you can say .help space .print to get help on this specific command. So it's not just it it isn't just one help command. There are plenty of help commands. There are at least 65 help commands. The library database. Oh, and here's the library ER diagram. Let's look at that. Oh, unfortunately, this one is a little bit harder to see. This is one that's this is actually a library of recipes. So forget about this one. This is this one that I use? I can't remember now if I use this in any of the lectures. Sequila is a very common database. Oh, this is an important file. So later, I'm going to go over some individual SQL commands, and they're all in this scratchpad.sql file. And I'll actually modify this file. You might want to download this more than once because when I do this in the lecture, I may modify the file by adding stuff that occurs to me off the top of my head. Yeah, so this is uh, this whole thing can be entered into SQLite, but there are things here like this should be modified actually. So I can open a database. So I've been opening databases by saying, for example, SQLite 3 pets.db. I could do that. I did that before. But instead, I can just say SQLite, and I can then open pets.db. And now I have the same exact situation as I would have had by saying SQLite 3 space pets.db. So see, it says here that I'm connected to a transient in-memory database and that I should use .open file name to reopen a persistent database. And I can do that again. I can say open and now I can say .tables and I get the Chinook tables. I can say databases and I get what is it? Okay, Chinook is now my current database. And the RW just means that I can read and write that database. Okay, that's about all that I have to say right now about SQLite. We'll be talking about it a lot more and doing a lot more stuff with it as the semester progresses. So thank you for your attention, and I look forward to our next meeting.